Let's suppose we have this object here whose height we want to measure. And it's surrounded by a fence. So we can't actually take measurements to the foot of this object. It's not possible. And it's surrounded by the fence in such a way that we can't walk up beside this object even and lay down a measuring tape, say, directly across from the foot of this object. That's impossible. So we're assuming we can only make measurements on this section of ground here. So this object is on a hill which is at an angle of 10 degrees to the horizontal. We have a 100-meter tape measure and we have a clinometer for measuring angles. So here is what you could do. We could walk up to the object and take angles and take a measurement of the angle between this line here and the hill. Let's suppose that we get a value of 60 degrees. Now our clinometer, or whatever device we're using for measuring angles, might actually give us the angle between this line here and, say, the horizontal. But since we know that this angle in here is 10 degrees, same as this angle, these are corresponding angles, then if we get an answer of 7, if we get a value of 70 from our measuring device, we just have to subtract 10, so we know that this angle is 60 degrees. The next thing you could do is mark off a distance of 100 meters on the ground. So make this distance 100 meters. And then take a sighting from here to the top of this object. Now here we should get a smaller angle than 60 degrees. Let's suppose that this angle here is 40 degrees. Now, what can we do with this information? Well, let's just look at this purple triangle first of all. What we can do with this purple triangle is find this distance here, distance from here to here. The relevance of getting this distance will become clearer later. I'll just briefly outline the overall plan. The plan is to consider this right angle triangle here. All of this here is a right angle triangle. And if we know this side, well, we have the hypotenuse of this right angle triangle. We know that this angle in here will be 10 degrees. This angle is the same as this angle. Okay, we have this line here as horizontal line. Part of the calculation will involve getting this distance here, which I'll call y. So let's start by getting this distance here. We'll call it a, little a. Small letters are used for sides. If this side is little a, then the angle that's opposite little a is capital A. So we have a over sine A equals b over sine B. We're going to use the sine rule. We actually have all the angles in this purple triangle. If this is 60, the one next to it is 120. And if we have two angles, 120 and 40, then this third angle is 20 degrees. So we have three angles in this purple triangle and we have a side. Side is 100 meters. That's enough. That specifies this triangle fully actually. We can use the sine rule. We can say a over sine 40 equals another pair. So we need a pair, a corresponding side and angle. And if b is, we have to bring this in, b is the side we're given. It's 100 over sine b. So 100 is opposite 20 degrees. This distance is opposite this angle. So b over sine b is 100 divided by the sine of 20 degrees. So to find out what little a is, we just multiply both sides by sine 40. So a is 100 sine 40 divided by sine 20. You can do all that in one go on your calculator. To 2 decimal places, I get an answer of 187.94 meters. I'll round it to 2 decimal places. At the very end, I might round the final answer to 1 decimal place, or maybe just to the nearest integer. Okay, so that's A calculated. Now, if we're looking at this overall right angle triangle, I'll just draw it out here. We have A, which is 187.94. This angle here is 60 plus 10 is 70. We have enough information in this right angle triangle to find the side adjacent to it, which will correspond to this side here, call it x. So this is x. And I can find h plus y, which is just the sum of these two lengths here. See, we have a right angled triangle, we have an angle and a side. If I get h plus y from this, which I can say that sine 70 is opposite over hypotenuse. The side opposite 70 is h plus y. The hypotenuse is what we're given, 187.94. So the sine of 70 will give us this distance h plus y. But we're still left with the problem of getting y. You know, we have to subtract off y. So how are we going to deal with y? So there's no point in getting h plus y unless we know what y is. What about x? Well, how is x relevant to this? Well, if we know what x is, we can calculate y in this yellow triangle. If we know what x is, we have this yellow right angled triangle here. We have an angle of 10 degrees in it. And if we have a side, we can find y. And when we found y, we can just subtract from h plus y. But I'm going to get both x and h plus y here. So sine 70 is opposite over hypotenuse. The side opposite 70 is h plus y. The hypotenuse is 187.94. So we use the ratio sine, cos, or tan that brings in what we're looking for and what we're given. So we're dealing with a right angled triangle here. Now we could actually use the sine rule to solve this. We could say a over sine 70. Well, a is h plus y. What we're looking for. A over sine 70 equals 187.94 over sine 90. This is little b if you like, so this would be capital B. Capital B is opposite little b. Capital B is 90 degrees. The sine of 90 degrees is actually 1. So we'll have a over sine 70 equals this. You know, and then we just have a equals 187.94 times sine 70. Exactly what do we get here when we multiply both sides by 187.94. So the sine rule will work for any triangle. We could apply it here, so you don't even have to be memorizing your ratios for a right angle triangle. You can just apply the sine rule. Okay, so we multiply 187.94 by sine 70. That's 176.6 to 2 decimal places actually. So that's h plus y. Now we have to somehow get y. So we look to this yellow triangle here. We can't get y directly in this yellow triangle because we don't have any sides, but what we can do is we can get x. So let's get x. So you can see from this that x is the side adjacent to 70 degrees, so we could use cos. Cos 70 degrees is the side adjacent to 70, which is x, divided by the hypotenuse, which is 187.94. So we just multiply 187.94 by cos 70. So we get 64.28 degrees, or 0.28 meters, sorry. So now I can just look at this yellow triangle. The side adjacent to 10 degrees is 64.28. The side opposite 10 degrees is y. So to find y, I need to bring in these two. The side opposite and the side adjacent to 10 degrees. So that involves the tan of 10 degrees. So that's that calculation, and that's to get x. So now we have that the tan of 10 degrees in the yellow triangle is opposite over adjacent y divided by 64.28. So we can calculate y. We just multiply both sides by 64.28. To 2 decimal places, that's 11.33 meters. So if we want to find h now, we just plug this in here. So we get h equals 176.6 minus y. So we get an answer of 165.3 meters.